See the scary test SpaceX performed on the Starship with Heatshield. A spacecraft that re-enters Earth's atmosphere from orbit is moving at very high speeds, and with very high speeds I mean 7 to 8 kilometers per second. To land safely on Earth, the spacecraft must reduce its speed to a range where we can safely use a parachute so that they dissipate their kinetic energy by converting it into heat energy. The kinetic energy that the spacecraft has when it re-enters Earth's atmosphere is about 13 megajoules per kilogram, compared to explosives such as TNT, which has about 4 megajoules per kilogram. So the spacecraft has enough energy to vaporize almost everything we know of. But the good news here is that most of the energy produced on re-entry is absorbed by the atmosphere itself, and a small part is absorbed by the spacecraft. So how this kinetic energy is converted into heat energy? Hi, welcome to our YouTube channel. In this video, we'll dive deep into the heat shield of SpaceX's next generation rocket star. We will see why a heat shield is needed to re-enter the atmosphere, which is now used. Why is it so vital for the Starship? But before we start, please subscribe to our channel for the latest updates. So without wasting your time, let's get into it. So how this kinetic energy is converted into heat energy? In many sources, you will find that the reaction to atmospheric drag or friction is the mechanism behind this. While this is true for airplanes flying at supersonic speeds, but not for spacecraft re-entering Earth's atmosphere at supersonic speeds. When a spacecraft re-enters Earth's atmosphere at supersonic speeds, the atmosphere can't just escape. Airborne particles around the spacecraft try to reach the same speed as the spacecraft, generating tremendous pressure and extremely high temperatures, which leads to the formation of shock waves. Most of the heat is fed back into the shock wave, but also a small amount, about 1 to 5%, that the spacecraft must endure on re-entry develops temperatures that reach 1600 degrees Celsius. Heat shields. In order to protect sensitive instruments and the crew on board, the spacecraft needs heat shields that will emit or absorb heat on re-entry and keep objects inside the spacecraft in normal condition. The heat shield protects the structure from temperature extremes and thermal gradients through two main mechanisms: thermal insulation or radiant cooling. Isolates the main structure from the high external surface temperatures while emitting heat to the outside via thermal radiation. In order to achieve good functionality, the three properties required for a heat shield are low thermal conductivity or high thermal resistance, high emissivity, and good thermal stability, which is flame resistant. Highly emitting porous ceramics, HECs, are widely used to overcome these three properties due to the good thermal stability of ceramics, thermal insulation of porous materials, and the good radiation cooling effect that HECs offer. Types of heat shields. There are many types of heat shields. Spacecraft landing on planets with atmospheres like Earth, Mars, and Venus currently do so by entering the atmosphere at high speeds, relying on air resistance rather than rocket power to slow them down. A side effect of this method of atmospheric re-entry is aerodynamic heating, which can seriously damage unprotected or malfunctioning spacecraft structures. The aerodynamic heat shield consists of a protective layer of special heat dissipation material. Two main types of aerodynamic heat shields are used. Number 1, the ablative heat shield. Number 2, a thermal soak heat shield. The ablative heat shield consists of a plastic resin layer whose outer surface is heated with a gas, which then dissipates the heat by convection. The shield was used on the Mercury, Gemini, and Apollo spacecraft, currently used by the SpaceX Dragon 2 spacecraft, and is used on the Orion spacecraft. A thermal soak heat shield uses insulating materials to absorb and radiate heat from the spacecraft structures. This type is used in the Space Shuttle, which consists of ceramic or composite panels over most of the vehicle's surface, with a carbon-carbon material reinforced at the points of greatest thermal stress. This material damage to the wings caused by the Space Shuttle Columbia crash in 2003. With the possibility of inflatable heat shields being developed by the United States and China, it is believed that single-use rockets such as the Space Launch System will be upgraded with heat shields to save on expensive engines, likely to significantly reduce launch costs. SN-20 prototype need a heat shield. The SN-20 is the first Starship in the series to require a heat shield. Many previous models simply flew into the atmosphere without having to re-enter. These in turn must withstand temperatures up to 1400 degrees Celsius. Now that the spacecraft is at a launch site in Texas where it passes pre-departure tests, which could take place in late 2021. Although Musk thought everything was set and ready, the unthinkable happened during an ambient pressure test on SpaceX. We are talking about a heat protective tile, which had to be blasted during the test. Tiles which are fixed to the spacecraft with steel bolts should have no incentive to move from where they are attached. The exact cause of the accident is not yet known. However, Elon Musk tweeted that headed tank vent knocked off a few tiles. It is currently unknown whether the incident damaged the ship, although it is doubtful it was significant enough to delay the schedule. Then there's the cryogenic test and the moment all space lovers have been waiting for, the make or break static fire test. If successful, Starship will give SpaceX access to the solar system. Unlike Crew Dragon, which was designed to transport people to and from the International Space Station, this one is designed for the moon and possibly Mars in future generations. Elon Musk, founder of SpaceX, shared via Twitter rocket science YouTuber Everyday Astronaut, asked Musk how the tiles would hold up during the ascent. He wrote that, "I'm still a little surprised that nature didn't have the right idea and tiles are more like peeling force when climbing it would be. There is less room for the aerodynamic forces to tear it apart, and this will allow the steel to expand and contract." Everyday Astronaut says that unless the tile is very thin, hot plasma water drips from the edge of the tile, causing a hot zone. In response, Musk said, "I'm not quite certain that this couldn't be accomplished with numerous overlapping scales of metal sheets with an insulator between the scale armor and major structure. Existing tiles and attachment mechanisms appear to be prone to cracking and decay, which would not work if Starship 20 and future Starships were to survive re-entry. SpaceX needed to find a way to consistently create and install more permanent thermal tiles. When SN20 enters orbit, it will use a vacuum Raptor for the first time. This RVAC engine has a much larger nozzle than sea-level Raptors for atmospheric flight. We were unable to determine the method used to glue the loose tiles, or there may be less space between the tile and the rocket skin on those using the new gluing technique. If this is the case, the power behind the tiles, they may have taken them out. Also, in a controlled environment, the tiles of the shuttle are tested or changed. The footage of Starship's tile replacement released a few weeks ago is toxic. It is possible that these contaminants will prevent proper seal formation. It is also exposed to the weather in the upper bay. As a result of observations, the heating plate on the back of the SN20 was not removed. Since Starship exposes this side of the tile to the wind as it enters, it's technically a front. This is the nomenclature for aerodynamic vehicles. Normally, when you walk on the street, the front of your body beats in the air, and this is your front. When making this decision, do not take unusual actions such as to get back on the road, or the Starship shattered and collapsed, exposing the unprotected side of the wind. And if you happen to be standing in front of a jet engine or airplane propeller, look at the back of the jet's turbine blades and the back of the propeller blades. It is also supported by technical information. It would be awesome if the tiles on the launch pad didn't explode during the crash, and even more amazing if they survived the re-entry. Combining brittle tiles with rapid reuse is a contradiction. Rapid reuse requires the development of highly durable and low-maintenance thermal protection systems, which currently do not exist. 1 billion intricate individual elements, each requiring precise installation, removal, and inspection, will make it difficult to rotate multiple planes quickly. Friends, there is still a long way to go. The most difficult task is to get a quick return on investment, and thermal protection will be the biggest battle, which requires the greatest innovation. Several flights a day are impossible, but not impossible, let alone reusable. Many even said that Musk thought he had solved the tile problem with hexagons and the new attachment mechanism, and when he announced the system, many praised him as a genius, but nowadays the same people are calling the tile system bad. The problem SpaceX and Elon Musk might face is the rapid reuse after each flight. If they used a tiling system, these tasks would not be completed in hours or even days. Once we have a quick spin in our brain, we can actually see the problem. If the goal is still quick to reuse, changing the system now adds a year to the project. NASA and its collaborators have developed a method to preserve the tile of an orbiting spacecraft. You're unable to avoid the debris falling from the external tank and colliding with the orbiter during launch. This results in increased turnaround times due to inspection and replacement of tiles damaged by debris. On launch, they lose the STS-1 tile. It was the amount of Hermit energy they expended during launch that knocked them down. They then introduced a water-based suppression system to reduce the amount of energy reflected back into the shuttle stack. Alien debris is the shuttle's biggest concern when it comes to tiles, so Elon Musk could use the same method to improve on what was already done. Instead of a bunch of tiny hot tiles, how about a plate made of heat-resistant titanium with about a meter of insulating material between the plate and the car wall? Or choose a sturdier material that can withstand extremely high temperatures for long periods of time, and stop sticking spaceships with thousands of tiny tiles. What alternative do you think Elon Musk should use to cool the overheating plasma that the ship may encounter on re-entry? Please share your thoughts in the comment section below. See you again. Like, share, and subscribe for the latest updates. Thanks for watching.